Welcome fellow learners. In this video, we will learn how to do memory management in chatbots using Langchain. Most of you people have used ChatGPT multiple times, and you must have acknowledged this ChatGPT always remembers the previous question that you have asked to it and takes those questions into consideration whenever it is answering your next questions. So like I have asked it who won the FIFA World Cup in 2018 and it has provided the result France won the FIFA World Cup in 2018. And when I did follow-up question like which team did France defeated in semi-final, it answered like France defeated Belgium in the semi-final of the 2018 FIFA World Cup. So you can clearly see it takes into consideration of this only 2018 FIFA World Cup. But whenever you create a new chat window, it forgets all those chat history from the previous chat. So like I have asked the same question, which team did France defeated in the semi-final? And it provided the result like France defeated Morocco in the semi-final of the 2022 FIFA World Cup. It didn't take into consideration of the 2018 FIFA World Cup. So in this video, we will implement a similar use case using Langchain. So like we will see how we can save this chat history and utilize it while answering the user's follow-up question. And we will also see how we can use this chatbot in multiple sessions where multiple users can use this chatbot and ask the questions at the same time. So like we will create multiple sessions. Those multiple sessions will be mutually exclusive. One more thing, you can come back to this chat GPT at later time and you can still see the questions and the answer that it has provided to you are still there. So like it is saving it in some persistent memory. So in the similar way, we will also implement a persistent memory management in these chatbots using Langchain. So let's jump into the code implementation part. Let's take a look at this diagram which shows you how does this memory management work in chatbots. So like whenever user asks a question, that question will be stored in a memory. That memory could either be a buffer memory or a persistent memory. The question along with the past messages will be taken as an input to the prompt. So like whenever user asks its first question, that question solely will be passed to this prompt. But whenever user is asking a follow-up question or any subsequent question, that question will be appended with the past messages and will be taken as an input to the prompt. With the help of that question and the past messages, a complete prompt will be created. That complete prompt will be given as an input to the model. That model could either be a simple LLM or any agent or any chain. And output from that model will be passed to a output parser. It varies from use case to use case. So like in some cases, you just want raw text output from your model. So like if you ask who is the president of India, in that case, you might want just raw text output from the model. But in some cases, you might need to append an output parser and a tool after the model output. So like if you want your model or agent to send an email on your behalf, in that case, you might need to extract informations like email ID, email body, and subject from the raw text output from the model. Once you have extracted those informations, you might need to call a function or a user tool which will send an email on your behalf. Once you have completed those steps, you have got your final answer or final output. You can showcase that final answer to your user. And also you need to save that answer to your memory such that that answer can be utilized in the next step. Whenever user asks a follow-up question, that answer will be passed as a past messages or a chat history. So this is the complete architecture that we can utilize to see how does this memory management work in chatbots. So let's first write down what are the different steps that we are going to follow in this notebook. In the first step, we will import an LLM. We will be utilizing OpenAI chat model over here. In the second step, we will bind this LLM with a tool. We will be utilizing Wikipedia as a tool over here. In the third step, we will create a prompt template with chat history as its memory. Prompt template with history. In the fourth step, we will utilize this prompt template and this LLM and create an agent to test it out. Once we have tested out this agent with history, in the next step, in the fifth step, we are going to implement an automated history management using Langchain. In the sixth step, we are going to showcase this complete output in a Gradio UI. And in the final step, final seventh step, we are going to implement a persistent memory management using Langchain. So this will be our final and last step in this particular notebook. So let's finally jump into the code implementation part. As in the first step, we are going to import an LLM. For the LLM part, we are going to utilize OpenAI chat model over here. So to get that, we need to utilize this chat OpenAI module. And to use this chat OpenAI module, you need to install Langchain OpenAI. For that part, you can just do pip install Langchain OpenAI. And as I have already installed this Langchain OpenAI in this particular environment, I need not to install that. And once you have done that, once you have that Langchain OpenAI in your environment, you can run this cell, and this chat OpenAI module will be imported in this particular notebook. You can see I am using GPT 3.5 Turbo 0125 model over here. So this is the least costliest model available in the OpenAI. And I have already saved my OpenAI API key in my system variables. So I will be fetching that from there only. So let's run this cell, and this chat OpenAI model will be imported in this particular notebook. So let's run a simple query such that we can see like if it has imported correctly or not. So I've just asked hi to this particular chat OpenAI model, and you can see it has provided us result like, hello, how can I assist you today? So now we have imported this LLM in this notebook. So in the next step, we are going to bind this LLM with a tool. So for the tool part, we are going to utilize this Wikipedia tool. And to use a Wikipedia tool, you need to install Wikipedia in your environment. For that part, you can just do pip install Wikipedia, and that will install Wikipedia in your environment, in your Python environment. Once you have done that, you need to import two modules. One is Wikipedia Query Run, and another one is Wikipedia API Wrapper. This Wikipedia API Wrapper basically takes a Wikipedia API and conducts searches, whatever query you pass to it, and it will conduct a search in the Wikipedia and fetches the result from the Wikipedia. So for that part, you need to pass that Wikipedia API wrapper as an object to this Wikipedia Query Run, and we will be having an instance of Wikipedia in this notebook. So let's run this cell. And let's run a simple query such that we can see if this is working correctly or not. So now you can see it has provided us this result, and it is consist of lot of text over here. So this is the complete search that it has done through Wikipedia, and it has fetched all the text data that it has got in the Wikipedia. So to bind LLM with tools, that GPT 3.5 Turbo model with this Wikipedia tool, we need to create a list and pass that Wikipedia tool over here. If we need to use multiple tools, we can pass all those tools in this particular list, and then call a bind tools function and then pass that tools as an argument over here. So currently we are relying on OpenAI tool calling LLMs in this particular notebook, as OpenAI has fine-tuned their LLMs for the function calling such that they know when to call which functions and which arguments they need to extract, such that they can pass those arguments in the particular tools or functions. And also the reason behind binding these tools with the LLM is like we want to make sure that these tools are being passed every time whenever those LLMs are being invoked. So like this GPT 3.5 Turbo model, whenever we are invoking that GPT 3.5 Turbo model, we want this Wikipedia tool to be passed every time. So let's run this cell, and now this particular LLM is binded with this Wikipedia tool. So in the next step, let's create a prompt template. We will be adding chat history to this prompt template. So to create this prompt template, we need to import a chat prompt template module from Langchain core, and then we can call this from messages function to create this chat prompt template. You can see I have passed a list of arguments to this chat prompt template. So like the first argument is system prompt, and I have passed a simple prompt over here like, you are a helpful assistant, answer all questions to the best of your ability. Then after this, chat history will be appended. At the start, chat history will be empty. Then after chat history, user's input query will be appended. And after the user's query, agent scratchpad will be appended. So the agent scratchpad are kind of agent notepad that they uses to see what are the different intermediate steps that they have followed. So let's run this cell, and we have created this prompt, this chat prompt template over here. So now we have created the prompt template. We have imported our LLM. So in the next part, let's create an agent. As we are using OpenAI LLMs over here, and we are going to create a custom agent, we need to import two modules. One is OpenAI tools agent output parser. This will be used to basically convert output from LLMs and parse them into a specific format, such that if it wants to call a particular function or particular tool, like in our case, it wants to call a Wikipedia tool. So as per the Wikipedia tools requirement, it will fetch the arguments that are going to be passed in that particular tool or function. And the second, this particular module, format to OpenAI tool messages, will be used to convert the agent, basically agent actions and their different output from the tools to function messages such that they can be passed to agent scratchpad. So let's run this cell. And once they have been imported in this notebook, let's create this particular agent. So as you can see, I have created a runnable sequence over here. So like the first part in this runnable is this particular input to this prompt. So like users input query, agent scratchpad, and chat history. These inputs will be passed to this prompt, and complete prompt will be passed to this LLM. This LLM with tool is basically binded GPT 3.5 turbo model with that Wikipedia tool, and the output from this LLM with tools will be passed to this OpenAI tools agent output parser. So in this way, we can create this agent. So let's run this cell, and then we can create an agent executor which will be basically used to test it out, test all those query and run all those query. So for the agent executor part, we need to pass agent, then all the tools that we are going to utilize. And I have also passed this verbose equals to true to see what are the different intermediate steps that this agent executor has followed. So let's run this cell. And this agent executor has also been instantiated in this particular notebook. So now let's test out this agent. To test out this agent, we need to pass two things as an input. One is user's input query and another one is chat history. So at the start, chat history will be empty. And for the chat history part, we are going to utilize this chat message history from this Langchain, which is basically a module that has already been implemented in this Langchain, and it basically stores list of messages in memory. So let's run this cell, and let's run a query. I have asked a simple query like who won FIFA 2018 World Cup. So let's run this cell and wait for the response from this agent. So you can see like it has first invoked this Wikipedia tool, and it fetched out all those data from that Wikipedia query. And then you can see it has provided this final result, like France won the 2018 FIFA World Cup by defeating Croatia by 4-2. So this way it has run that agent. And let's add those input query and output from LLM to our chat history, such that that chat history can be utilized in the follow-up question. So like at the start, you have seen chat history was empty. But whenever user asks a follow-up question, chat history will already be filled with some previous messages. So let's run this cell, and you can see chat history consists of both human input like this user's input query who won the FIFA 2018 World Cup, and response from AI like France won 2018 FIFA World Cup. So now we are having our chat history with us. We are having this agent. So let's run a follow-up question. So I have asked like, and which team Croatia defeated in semis? So let's run this cell, and let's wait for this agent's output. So again, you can see this agent is invoking this Wikipedia as first step, and then it has fetched out these information from Wikipedia. And finally, it has provided result like Croatia defeated England in the semi-finals of 2018 FIFA World Cup, which is correct answer. So we can clearly see that it remembers the past conversation, and it takes into account that it needs to answer about 2018 FIFA World Cup only, without being explicitly mentioned by user in the follow-up question. But we can also see that there are some external management required, like we need to add user's query and corresponding LLM output as in separate line of code. And also we cannot use this in multiple sessions. So like if multiple users wants to use this chatbot at the same time, we cannot use this. So what we can do, we can utilize Langchain, and we can create an automated history management with multiple sessions. So to implement that, we will first create an empty dictionary. The keys in the dictionary will be individual session IDs, and values will be corresponding chat history data. Then we will create an get session history function. This function will be responsible to return the corresponding chat history data as per the session ID. So like at the runtime, a session ID will be passed to this get session history function, and corresponding chat history will be returned by this function. One more thing is like sometimes the conversation could be too long, and we don't want to basically pass whole conversation, whole chat history to our LLM, because that would increase both the cost and the inference time. So for that part, I'm only passing the last 4 messages from the chat history to our LLM. There are some other ways which we can utilize to manage this chat history and then pass it to LLMs. So like instead of passing individual messages from the chat history to the prompt, we can summarize that chat history and then pass the summarized chat history to our prompt. And one other way is to like extract the important entities from the chat history and then pass only those important entities and important basically keys from the chat history to the prompt, such that it cannot basically increase the cost and it can reduce the inference time also. So let's run this cell. Now to implement this whole automated history management with multiple sessions functionality, we need to import this runnable with message history module. This module is a runnable that manages chat message history for another runnable. In our case, another runnable is our agent executor. So let's run this cell and import this module. Now you can see to initialize this module, I have passed 4 parameters over here. The first parameter is another runnable, that is our agent executor. The second parameter is this get session history. It is the same function that we have created over here. This function takes session ID as an input parameter and return back the base chat message history. As you can see, docstring for this particular function, there are different parameters that we can pass over here. So I have passed 2 more parameters. The first one is input message key. So input will be treated as input message key and chat underscore history will be treated as our history message key. So let's run this cell and initialize this module. Now we can run this chain with message history directly over here, as this creates a runnable that is a wrapper around this agent executor that we have already created, and it also takes into consideration of this particular get session history function. So let's run this cell. There is another thing that you might notice, that apart from this input, I have passed another dictionary which is having a key configurable. So like the first dictionary will be taken as an input to this particular runnable, that agent executor, and the second dictionary will be taken as an input to this get session history function. So like this session ID will be extracted from here and then it will be passed to this particular get session history function. So let's run this cell. As now we are only running for the demo purpose, we have not given it a particular session ID. We have given a just simple draft session ID over here. So you can see it has provided us the result like, hello, how can I assist you? And the input was hi, chat history was empty, and the output was this. So in this way, we can run this particular runnable, runnable with message history. One more thing is like there is a warning. So next I will be setting up the log level. I will be setting the log level to error only, so such that we can ignore this warning over here. Now to showcase the complete functionality, how this particular chatbot can be used with multiple sessions and how this can manage the chat history, we will be creating a Gradio UI and we will be showcasing the complete output over there. So for that part, you can see over here, I have first created a state object. So this state object will save the current session ID for only the current session, and whenever a next session will be created, this state will be changed. So according to this, I have written the code in this function, particular this response function. And before going into that, I have created these 3 other objects. So like one will be the chatbot, where our basically the user's input question and the corresponding AI output will be shown. The second one will be the simple text box where user can input their question. And the last one is basically a clear button on which you can click and then clear all the chatbot and the corresponding user's input text box. So now if you go through this respond function, I have created a if condition over here. Like if the chatbot history is empty, like if you see whenever you create a new session, chatbot history will be empty. So in that case, we will create a new session ID. So like whenever you click on clear button, the chat history will be empty. In that case also, new session ID will be created. And whenever you use the same link or use the same chatbot in another tab, or another user comes up and uses the same chatbot at the same time, this session ID will be again created as a new. So in this way, we can implement this chatbot with multiple sessions. So now after this, I have just invoked this chain with message history, and it will take input message from the user input query, and then pass the particular session ID such that at the runtime it only fetches the chat history that is basically corresponding to that particular session only. And then I have appended the input user's query and the corresponding LLM output to this chatbot history. This is only to showcase in the UI. So let's run this cell and test it out in Gradio UI. So let's click on this link and see how this particular memory management works in multiple sessions. So let's ask a question. So I will first introduce myself, like my name is Atul. Can you tell me which team won 2018 FIFA World Cup? So it will first call the that Wikipedia tool, fetch results from there, and then pass it to our LLM GPT 3.5 Turbo model and provide us the answer. So like you can see, the team that won 2018 FIFA World Cup was France. Now, if I ask a follow-up question, let's say I ask it, what is my name? So it should provide my name as Atul because I have provided it in a previous step. So like you can see, it has given like your name is Atul. Now, if we use this same particular URL, like this same URL, chatbot URL in a different session by creating a new tab, and then if I ask what is my name, and let's see how does this respond back. So like you can see, I'm sorry, but I don't have access to your personal information such as your name. Now you can clearly see when we are asking the question about the name in this particular tab, it is able to give us the response because it is saving the chat history for this particular session. But when we have created a new tab, it has created a whole different session. So as per our code, it will create a new session ID and only save the chat history that belongs to that session ID only. It does not take into account the chat history from the previous session. So that is why it is only taking into account the chat history that belongs to this session. So now you might have got good understanding of how we can create or how we can manage memory in chatbots even using multiple sessions. But one thing is like whatever memory or chat history that we are using here, it is kind of a buffer memory. It is being stored in a RAM or buffer memory. What if we want to use this memory at later step or use this chat history at later step? For that part, we need to create a persistent memory management. So to implement this persistent memory management in this notebook, we are going to utilize SQL database. And to get SQL database and save our chat histories into SQL database, we will be importing this SQL chat message history module over here. So this will create a chat message history that will be stored in a SQL database. So let's run this cell and it will import this SQL chat message history in this particular notebook. And if you hover over this particular SQL chat message history, you will find out what are the different parameters that we require to pass to this particular module to initialize it. So you can see I have passed this session ID, a default session ID name over here. And I have passed this connection string, like I want to create this memory underscore DB database. And we can also pass this table name. But if we do not pass a table name, it will take message underscore store as default table name. So let's run this cell and it will create a SQL chat message history. Now, if we see at the start, there will be nothing in this particular table, that is this particular table, message underscore store. So let's test it out and check what are the initial data that has been written over this particular table under this database. So if we run this particular command, or basically SQL command, like if we select all the data from this, there will be no data inside this table as we have just created this table. Now let's add few data into this, like let's add a user message hello, and then add a LLM output or AI output message to this. Now let's see what kind of schema is being written over this table under this database, memory database. So you can see it creates this type of particular schema. Like it will be storing a unique ID, I think one, your particular session ID, and then corresponding data over here. Then a second data will be appended like this. Like 2 will be unique ID, then test session will be the same session name, and then corresponding data. Like you can see here, the type is, first one is human, as I have added this add user message, and second one is type is AI. So in this way, the Langchain has implemented these function. So it makes pretty easy for us to basically add those messages and then define what kind of messages those are. So now next we will be using the same get session history function that we have used earlier. The only difference is that we are not going to use any dictionary over here. We will be using this SQL chat message history, and we will be passing particular session ID to this SQL chat message history. So like at runtime, whenever we pass a session ID to this function, it will fetch the corresponding data from this database. This let's change the name of this database, as we have used earlier is memory under .db. So let's make that over here also. Now it will fetch the corresponding data as per the session ID from this database directly. So let's run this cell, and you can see other things are same, like the first parameter in this runnable with message history same, agent executor. Then this function get session history is also same. All those other things are same. Only difference is, like instead of dictionary, we are going to use this persistent memory using this SQL database. So let's run this cell, and then we can invoke that chain with history that we have created over here, and we can pass particular session ID over here. So this will be a dummy session ID that we are going to pass, and let's run this cell and let's see how does this gives us result. So like you can see, it has given hello, how can I assist you today. Now if we basically run this command, if we basically see does that message has been stored in this particular you can say table of message underscore store of database or DB or not. So you can see apart from these two particular input that we have provided to it earlier, when we invoke this particular query, it has added these 3 and 4 also, like this 3 human hi, and then corresponding 4 hello, how can I assist you today. So in this way, you can also implement a persistent memory management using Langchain. So great. I think you have got good understanding of how to do memory management in chatbots. You have also got understanding of how you can create buffer memory, and also you have got understanding of how you can create persistent memory management using Langchain. So great. Thanks for making till the end of this video. Goodbye until the next time.